All right, let's get started. I'm going to do a video here showing you how you could teach graphing sine or cosine. And what's great about this technique is that it works for any type of a function, including, well, it works for any type of a function, not just for trig functions. Hello and welcome. I'm going to teach you a technique for teaching graphing sine or cosine. What's great about this technique is that it works for any type of a function, not just a trig function. So first of all, your students should be familiar with graphing any sine or cosine curve. So when I introduce the sine curve, I often talk about how it starts in the middle and then it goes high and then back to the middle and then low and then back to the middle. And so that's always going to be the pattern for a sine curve. And the cosine curve has a different pattern where it starts high and then goes to the middle and then low and then back to the middle and then high. And then I'll call these the 5 key points. And these 5 key points the students should be familiar with. So they should be able to do the x's at 0, pi over 2, pi, 3 pi over 2, and 2 pi. And of course, they do relate to the unit circle. So it's going to be 0, and then pi over 2, and then pi, 3 pi over 2, and 2 pi. So as long as they're pretty comfortable with the unit circle, then they should be comfortable with getting these x coordinates as well. Okay. So the steps that I'm going to go through are we're going to create a t-table with the 5 points for the parent graph. So it would either be these 5 key points for a sine curve or these 5 key points for a cosine curve. Then we're going to analyze the function. So we need to determine what the transformations are. So we'll do the amplitude and the period and the phase shift and the vertical translation. Now you'll notice in this little organizational chart here, I've separated them into according to which ones affect the x coordinates of the graph, like affect the graph horizontally, and which transformations affect the graph vertically. So that's going to be useful later. And of course, the period, since it changes, is basically going to be a horizontal stretch or shrink. Then if that affects the graph horizontally, and a phase shift, of course, just shifts the graph left or right. And then the amplitude is a vertical stretch or shrink, and then the vertical translation is just a vertical shift up or down. So then you're going to figure out what your new coordinates are going to be. So you're taking the 5 points from the parent graph, and we're going to use the period, then the phase shift to adjust those x coordinates from the parent graph's t-table to make new x coordinates. And then we'll do something similar for the y coordinates. We're going to use the amplitude, and if there is any sort of a reflection in the x-axis, then the vertical translation. You'll notice that I have the word then here because the order does matter. You need to make sure that it's basically the order of operations. Sometimes I'll teach my students to do D, R, S. So that would be dilation. So that's your stretch or your stretch or your shrink, reflection, and then your shift always comes last. But basically, again, it's the order of operations. So you need to do any multiplying or dividing first, and then do any adding or subtracting. All right, let's get started with an example. It says that we're going to sketch 2 periods of the graph of -3 sine of 2 times x minus pi over 2 minus 4. So I picked an example that has all 4 different transformations. So let's start by doing a bit of analysis. I'm going to zoom in here so I can get a lot of information on this slide. So the amplitude, well, looking at my equation here, the amplitude is going to be 3, and then that negative means it's going to be a reflection in the x-axis. Let's also then talk about the period. And the period, this is their b value. So our period is going to be 2 pi divided by 2. So that's just going to be pi. Then the phase shift. The phase shift, that's going to be this minus pi over 2 here. So it's just going to move to the right pi over 2. So you can just say pi over 2, or if you want to be a bit redundant, to the right, pi over 2 to the right. But technically, you can just leave it as pi over 2. If this had been a positive here, then you would have to indicate that it's going left pi over 2, or you could say that the phase shift is negative pi over 2, depending on what you prefer. Or if you're a student watching this, whatever your teacher prefers. All right, and then the last transformation is going to be the vertical translation, which is it's a -4 here, so of course that means we're going to go down 4. All right, I'm kind of going out of order of what I just said over here. I said the first thing we're going to do is make a t-table with the parent graph. So let's go ahead and add that on here. I just got so excited about transformations, I just did that first. All right, so my parent graph, since this is a sine function, okay, my parent graph t-table, let's write that down. So I'm just going to write x and then sine of x. If you're making a t-table, you should always label what your columns represent. So it's going to be 0, pi over 2, pi, 3 pi over 2, and then 2 pi. Those are my 5 key points. And then the sine function starts in the middle, so it's going to be 0, and it's going to hit the middle again at pi and again at 2 pi. It's very convenient that these three are always going to be the same. And it's going to go up to 1 at pi over 2, and it'll go down to -1 at 3 pi over 2. So students need to have this memorized or be able to easily recall it. Again, it's all just based off of the unit circle. All right, now looking at our transformations here, the amplitude and the reflection in the x-axis both affect the graph vertically. So what this means is we are going to, the amplitude is 3, so that's got vertical dilation or vertical stretch. So we're going to multiply all of your y values by -3. We're doing the negative because of reflection of the x-axis and 3 because of the amplitude. It's essentially the same thing as whatever came up here in front of the function. Now, for the period, that is a horizontal dilation or a horizontal stretch or shrink. Now, since our period has decreased down to pi, that is a horizontal shrink, which means we're going to multiply the x's by 1/2. Or, of course, you can say divide all your x's by 2, but I just prefer multiplication. Okay, so that's going to shrink your graph horizontally. So that's what your period does. It affects the graph stretch or shrink. And similar to any other type of function that you may have studied or your students may have studied, it's always going to be the reciprocal of this number here that goes inside the function. So if this were 3, we would multiply everything by 1/3. If this were 2/3, we'd multiply everything by 3/2, etc. All right, next up, we have the phase shift, and that's just going to shift it to the right. So that's, again, affecting your x's. So we're going to add, maybe I should write this in green, add pi over 2 to the x's. And then the last one, the vertical translation down 4. I just realized I should move this over. I need to label this as vertical translation. There we go. So again, the vertical translation down 4, that means we're going to subtract 4 from the y's. That means we're going to subtract 4 from the y's. All right, now let's set up our new t-table. All right, I've set up my new t-table with my 5 key points, and I just labeled it x and y because my function here is called y. If this were called f of x, I could call this f of x here. So we're going to take, let's start with the x's. So we have multiply the x's by 1/2 and then add pi over 2 to the x's. So we're going to take each one of these x's from the parent graph and we're going to do those 2 transformations. So I'm going to take 0, I'm going to multiply by 1/2, and I'm going to add pi over 2, and that's going to give me pi over 2. Next, I'm going to take pi over 2, I'm going to multiply by 1/2, and I'm going to add pi over 2. Now, this is going to be one area that your students might not love this because they're having to do work with fractions. So if it helps to sort of write it off to the side or something, so we're going to take pi over 2, we're going to multiply by a half, which is pi over 4, and then you're going to add pi over 2, which is the same thing as 2 pi over 4, so then you can see you're going to get 3 pi over 4. Next, we have pi, multiply by half, and add pi over 2. When you take pi, multiply by half, it's going to be pi over 2, plus pi over 2, that's just going to be pi. 3 pi over 2 times a half, that's going to be 3 pi over 4. Might want to write this one down. 3 pi over 4, and we're adding pi over 2, or again, it's the same thing as 2 pi over 4. So that's going to be 5 pi over 4. 5 pi over 4. And finally, we have 2 pi multiplied by half. This is going to be 1 pi, and 1 pi plus pi over 2. That's going to be like 1.5 or 3 halves. All right, that's probably the worst of it, the dealing with the fractions. The y's should be much easier and faster. So now for the y coordinates, we're going to first multiply each y by -3, and then we're going to subtract 4 from y. So starting with 0, and another nice thing, again, these three are identical, so we only have to do it once. So 0 times -3, of course, is 0. Subtract 4, -4. So we'll have -4 here, and here, and here. Then 1 times -3 is -3, minus 4, that's -7. And finally, -1 times -3 is +3, minus 4 is -1. All right, so there's my t-table. So the next step, which I have over here, oh, I don't have it over here, is we're going to set up our t-table and our graph, and we're going to plot the points. All right, when I'm doing this with my students, I don't often give them graph paper because I feel like if you give them graph paper that has the grid lines already printed on it, then the students get confused about how to label their scale. Where if you give them, if you have them do their own graph paper, then they don't really need to be limited to the amount of grid lines that are on the graph that they have. Of course, if you just get graph paper that you could buy from the store, then that could work as well. And really, when I tell the students is if you mess up the graph, it's easy for me to grade it by looking at their t-table. So I really would want them to include their t-table. You can even put in instructions on an assessment. Please include your t-table. All right. So now for the scale, I notice that I have to start at pi over 2 and I go to 3 pi over 2. That's not that much distance. I do have to do 2 periods, however. And then from pi over 2 to 3 pi over 4, that's just a distance of pi over 4. So I'm just going to make every little grid line be pi over 4. So I'm going to kind of go, let's see, let's just do a bunch of tick marks here. 1, 2, 3. All right. And each one is going to be pi over 4. So I'm just going to label every other one. So that'll be pi over 2, and that's going to be pi. That'll be 5 pi over 2, and then that will be 3 pi over there. Okay, so I probably have too many tick marks, and that's okay. Now, for the y coordinate, of course, when I was making my grid, I already knew that I had to go down to -7 and -1. So I really kind of need more space on here in the negative y than I do at the top. So I'm just going to get down to -7. So there's -7, that's -5, -3, -1. So when I'm grading this for my students, I do pay attention to their scale, because what you don't want, and I see this a lot, is students will set up like the first grid line they'll say is pi, and the next one they'll call 3 pi over 2. And then I'll say, nope, that doesn't work. You're saying that the distance between 0 and the first tick mark is pi, but then the distance between the first tick mark and the second tick mark is pi over 2. You can't have that. Your scale is off. And then I do penalize them for that. So they need to pay attention to that. And now we can just plot our points. So at pi over 2, down at -4, 3 pi over 4, that's the very next tick mark, is negative 7. At pi, we're at negative 4 again. At 5 pi over 4, we're at negative 1. And 3 pi over 2, we're down to negative 4 again. So that's going to be, here's the shape here. That's going to be one period. I'm a bit off there, but that's okay. And it did ask me to graph 2 periods of it, so I just need to repeat that same pattern. So of course the pattern I notice is it's a tick mark, a plot, tick mark, you plot, tick mark, you plot. Because sometimes the pattern is you have to skip a tick mark before you plot another point, or skip 2 tick marks or whatever. So this means that my next point to plot is going to be the very next tick mark. I have to go down to negative 7. And the next tick mark will take me back to negative 4. And the next one up to negative 1. And then finally at 5 pi over 2 will take me back down to negative 4. So there's my next period or my next cycle. Voila. And of course, you could test that from here, from pi over 2 to 3 pi over 2, that's a distance of pi units. And then here you have a distance from 3 pi over 2 to 5 pi over 2 is another distance of pi units. And you've also got a middle, instead of going middle, high, middle, low, it's middle, low because of the reflection. So we're looking at middle, high, middle, and another one, middle, low, middle, high, middle. And there we go. Voila.